Welcome to the Wonder Fungi Podcast. Today, we are saving you money.
We certainly are. And,
Yeah.
I'd argue we're going to save you a significant amount of heartbreak and frustration along the way, too.
That is the goal. I was looking at my bank statement the other day, and I was scrolling back to when I first got into, say, photography. And then when I got into coffee brewing.
Oh, yeah.
And now, looking at my entry into mycology, there's this pattern. I've started calling it the hobby tax.
The hobby tax. I like that.
Yeah, you know what I mean? It's that inevitable phase where I have absolutely no idea what I'm doing, but I have a credit card and a very, very convincing Amazon algorithm.
It knows you better than you know yourself.
It really does. I'm up at 2 a.m. looking at these super specialized tools, things I can't even pronounce. And I somehow convince myself that if I just buy the expensive thing, I'll magically be good at the hobby.
Ah, yes. You are describing a very, very well-documented phenomenon. We call it GAS.
GAS.
Gear Acquisition Syndrome.
Gear acquisition syndrome. Wow, that hits a little too close to home. But it turns out growing mushrooms, mycology, is absolutely rife with this, isn't it?
It is rampant. It's
Yeah.
one of the worst I've seen, actually. And it's so fascinating because if you really stop and think about it, fungi are some of the oldest organisms on Earth.
Right, they've been around forever.
For millions and millions of years, they've been growing successfully in the chaotic, messy, competitive environment of a forest floor. They didn't have Bluetooth humidifiers.
No digital temperature controller.
They certainly didn't have HEPA filters. Nature is just, it's messy.
And it works.
Exactly. But when we humans try to bring that process indoors, our instinct is to over-engineer it. We want to control every single variable. We see these sleek, automated grow tents, digital foggers, complex fan systems, and the marketing tells us this is how the pros do it.
And the logic is so seductive, it just makes sense on the surface. If I spend $500 on a setup, I will get $500 worth of mushrooms.
Precisely. It's the idea that more gear equals better results. But our whole mission for this deep dive today is to completely dismantle that idea.
Not just question it, but dismantle it.
Entirely. We are going to strip away all the marketing fluff and look at the actual physics, the chemistry, and the biology of how these organisms grow. And the surprising truth, the thing that might make some equipment manufacturers a little bit angry, is that in mycology, low-tech often yields superior results.
Okay, hang on. Superior. You're not just saying good enough for the cheapskates, but actually better.
Better. Because the low-tech methods, the simple methods, they usually align much better with the actual biology of the fungus. The high-tech gadgets, on the other hand, often try to force the organism to behave in ways it just doesn't want to.
I love that. We're going to use science to justify being cheap. That is my absolute favorite kind of science.
It's not cheap science, it's efficient science.
Okay, I'll take it. All right, let's get into the weeds, or I guess into the substrate. I want to start with the very first thing that tripped me up when I started reading the forums. It's the most basic supply you need, the cleaning agent.
Sterilization. The foundation of everything.
Right. We know that mushrooms hate competition. We don't want mold. We don't want bacteria. We need a sterile environment. So I go to the pharmacy, I walk down the aisle, and I see isopropyl alcohol.
Yep.
And there's a bottle of 70%, and right next to it, a bottle of 99%. Now, I'm a simple guy. I see numbers. 99 is bigger than 70.
Therefore, it must be stronger, more powerful.
Of course. If I want to kill germs, why would I dilute the poison? Why would I want 30% of my bottle to be just water that feels like a ripoff? I want the pure stuff. I want the nuclear option.
That is the most intuitive, most common sense assumption you could possibly make. It makes perfect logical sense.
Right.
And it is completely scientifically wrong.
Okay, hold on. You're telling me that if I take pure alcohol, which we all know is a disinfectant, and I water it down, it becomes more lethal. That sounds like some kind of, I don't know, homeopathy or something. How on earth does that work?
It all comes down to the cellular mechanics. We have to look at what we're actually trying to kill. We aren't just trying to make the bacteria wet or annoy it. We are trying to destroy it.
We want it dead, not just sleeping. Dead.
Dead. Specifically, we want to denature its proteins and rupture its cell wall. We want to break it open from the inside. Now, when you use 99% isopropyl alcohol, which is basically a pure solvent, it attacks that cell wall extremely aggressively. It acts incredibly fast.
And fast is good, right? If I'm wiping down a table, I want those germs dead instantly.
You'd think so. But in this specific case, fast is actually the problem. The sources you pulled for this deep dive use a fantastic analogy, and I want to stick with it for a minute. Have you ever made pancakes?
I have made some. Very questionable pancakes in my time, yes.
Okay. Imagine you have a pan on the stove and you crank the heat up to the absolute maximum.
Yeah.
The pan is literally smoking hot. You pour your batter in. What happens to that pancake in the first 3 seconds?
Oh, it sizzles like crazy. The outside gets that black, crispy char almost immediately. It burns.
Exactly. You get a crust, a hard burnt crust. But what is happening on the inside of that pancake?
It's still raw. It's basically just liquid batter in there.
That is exactly what happens to a bacteria cell when you hit it with 99% alcohol. The alcohol is so concentrated, so potent, that it causes the proteins on the very outer surface of the cell wall to coagulate instantly.
It cooks the skin.
It forms a crust, a hard, protective, coagulated protein shell. And because that shell forms so quickly, we're talking microseconds, it actually seals the cell off from the outside world.
Wait a minute. So the alcohol basically builds a bunker for the bacteria.
Precisely. That coagulated layer becomes an impenetrable barrier. The alcohol can't get any deeper because it blocked its own path. So the inside of the cell, the nucleus, the living machinery, is perfectly safe. The germ isn't dead.
It's just dormant.
It's hiding in what you could call an alcohol-induced bunker, waiting for the threat to pass.
It's hunkered down in a panic room made of its own skin.
That is a terrifyingly accurate way to put it. It's just sitting there waiting. And once the alcohol evaporates, which happens very, very quickly with 99%, the cell can eventually repair that surface damage and wake back up. And then you have contamination.
That is wild. So I'm scrubbing my grobe in with the expensive stuff, thinking I'm being extra careful, but I'm basically just knocking on the door and running away.
You're just scaring them into hiding. Now, let's look at the cheap stuff, the 70% alcohol. That other 30% is water. And that water is not just a filler to save the manufacturer a few cents.
It's an active ingredient.
The water is the catalyst. It's the most important part of the equation.
So the water actually plays a role in the attack. It's not just a bystander.
A crucial role. For one, water slows down that whole coagulation process. It prevents that instant crust from forming. It keeps the cell membrane channels open. Think of the water as a negotiator that keeps the door open just long enough for the alcohol to slip inside.
So it's a Trojan horse.
It's a perfect Trojan horse.
Yeah.
Because the solution is diluted, it doesn't just flash burn the outside, it permeates. It soaks through the cell wall and gets into the cytoplasm, the gooey center of the cell where all the important stuff lives.
And once it's inside?
And then it goes to work. It coagulates the proteins from the inside out. It lyses or ruptures the whole thing. It doesn't just put it to sleep, it kills the organism completely. There's no coming back from that.
So by being weaker, it's actually more insidious. It gets deeper.
Slow and steady wins the race.
Yeah.
And slow brings us to the second critical reason why that water is vital: evaporation.
Right. I've noticed when I use 99% to clean like thermal paste off a computer chip or something, it's bone dry in like 5 seconds.
It's highly volatile. In sterilization, we talk about dwell time or contact time. It's a critical concept.
Yeah.
For any disinfectant to work properly, it needs to be in physical contact with the pathogen for a certain minimum amount of time. If you spray 99% alcohol, it might just vanish before it even finishes the job.
It ghosts you.
It absolutely does.
Yeah.
But the 30% water content in the 70% solution, it acts as an anchor. It dramatically slows down the evaporation rate. This ensures that the surface stays wet and lethal long enough to actually kill hardy mold spores or bacteria.
Okay, this sounds great in theory, but is there actual data on this? I mean, have they tested this on real bugs?
Oh, absolutely. This is settled science. The research you found included a specific data point that I found really compelling. They tested various solutions on Staphylococcus aureus, staph.
Okay, nasty stuff. Not something you want anywhere near your mushrooms or your body.
Definitely not. They took a 50% solution of alcohol, so even weaker than the 70% we recommend, and applied it. And it killed the staph bacteria in about 10 seconds.
10 seconds. Bam. Gone.
Then they tested a 90% solution. So much stronger, nearly pure.
Which you would think would be instant death. Like half a second.
It failed to kill the bacteria even after 2 hours of contact time.
Get out of here. 2 hours. You could soak it for 2 hours and it's still alive.
Still viable. Because the organism went dormant. It protected itself with that protein crust we talked about. It just waited it out.
That is absolutely mind-blowing. It completely flips the script on more is better. So the takeaway is, by buying the weaker stuff, you are actually getting the stronger killer.
Exactly. Now, I will say, 99% has its place. It's a fantastic solvent. If you have sticky tape residue on your tub, or if you're cleaning electronics where any amount of water could cause a short circuit, use the 99%. It's great for that. But for biology, for killing things, It is the inferior tool for the job.
So, step one of saving money. Put down the expensive bottle. Buy the cheap stuff. Your mushrooms will thank you.
And your wallet.
I feel like we've just saved the listener $5, but more importantly, we've probably saved them from a completely ruined harvest. Okay, so we have our chemistry sorted. We have the right weapon. Now we need a battlefield, a place to do the work.
The workspace. The clean space.
And this is where the gear acquisition syndrome really kicks into high gear. Because if you go on Instagram or YouTube, you see the pros. And what do they all have? They have these massive, humming, stainless steel units glowing with blue lights, the laminar flow hood.
It's the altar of mycology, the holy grail.
It looks so cool. It looks like a real laboratory. And then I look at the price tag, $500, $800, $1,000 or more, and I think, well, if I want to be a serious grower, I guess I need that.
And look, for a commercial mushroom farm, if you are growing 500 pounds of oyster mushrooms a week for restaurants, you absolutely do need that. It's a required tool for that scale. But for the home grower, for you, it is massive overkill. And surprisingly, there is a $30 alternative that uses pure physics to be just as effective.
The glorious still air box.
The SAB.
Which is, and let's just be honest here, it's a little embarrassing to describe. It's a plastic storage tote that you flip upside down and cut 2 holes in for your arms.
That is exactly what it is. A simple, elegant solution.
It feels wrong, though. It feels so janky. How can a plastic box from Walmart possibly compete with a HEPA-filtered, motor-driven, $1,000 flow hood?
It all comes down to understanding how air works. There are really 2 main philosophies for dealing with airborne contaminants. The mold spores, the dust, the bacteria, they are floating all around us right now as we speak.
They're everywhere, an invisible enemy.
Strategy 1 is what we call active filtration. Filter them out. Use a powerful fan to push a massive volume of air through a filter so ridiculously tight that nothing bad can get through. That's the flow hood. It creates a moving curtain of perfectly clean air.
Okay, that makes sense. Brute force.
Strategy 2 is let them fall.
Use gravity.
Use gravity, the most reliable force in the universe. This still air box relies entirely on the concept of dead air.
Dead air. I like the sound of that.
Think about the room you are in right now. The air seems still, but it really isn't. The HVAC is cycling. You're breathing. Every time you move your arm, you create a wake, a little turbulence. Dust motes are dancing around. You've seen them in a sunbeam, right? That chaotic swirl.
Yeah, that constant chaotic floating dust. You mentioned Brownian motion.
Exactly. In a normal room, those particles stay suspended because the air is always moving. It's turbulent. But inside a still air box, we are creating a tiny, contained microenvironment. You put the box on a table, you wipe the inside walls and ceiling with your 70% alcohol, and then, and this is the hardest part for people with gear acquisition syndrome, you wait.
You just wait. You don't turn anything on.
You step back, you go make a cup of coffee, you let it sit there for 30 to 60 minutes.
Why? It was happening inside.
You are waiting for gravity to win the battle. In that stagnant, enclosed, dead air, there are no currents to keep the dust floating. So slowly but surely, every single spore, every speck of dust settles down to the bottom of the box.
It just rains down.
It rains down. And once it hits the bottom surface, which you have thoughtfully sprayed with alcohol or soapy water, it sicks, it's trapped, it's out of the game. So the air above the floor of the box becomes perfectly functionally sterile.
So when I stick my hands in there to do my work, as long as I'm working in that middle column of air, it's just as clean as a laboratory.
It is functionally sterile, but, and this is huge, but it requires technique. It requires a fundamental understanding of fluid dynamics.
Okay, now you're going to scare me. Fluid dynamics sounds complicated.
It's simpler than you think. We just need to talk about something called the Reynolds number.
I think I remember hearing that in a high school physics class and then immediately forgetting it. Remind me what that is.
In really simple terms, the Reynolds number is just a way to measure how turbulent a fluid is. And remember, air is a fluid. If the number is low, the flow is smooth and predictable. We call that laminar. If the number is high, it's chaotic and unpredictable. We call that turbulent.
Give me a visual I can hang on to.
Okay, imagine a kitchen faucet. If you turn it on just a little tiny bit, the water comes out like a perfect, clear glass rod. It's absolutely smooth. That's a low Reynolds number. Laminar flow.
Got it.
Now crank that handle all the way open. The water sprays everywhere. It splashes. It's full of bubbles. It's a chaotic mess. That's a high Reynolds number. Turbulent flow.
Okay, I'm with you.
Inside the still air box, your hands are the faucet. If you stick your hands in and start thrashing around, moving fast, jerking the jars, twitching your fingers, you are creating high Reynolds number turbulence. You are acting like a hand-cranked mixer.
And all that wind you're creating just picks the dust right back up off the floor and throws it into the air.
Precisely. You resuspend every single contaminant you just spent an hour waiting for to settle. So working in SAB requires a sort of, a Tai Chi discipline. You have to move slowly, you move deliberately, you plan your movements. I am going to reach for the scalpel now.
Your goal is to keep the air dead.
So it's almost a mindfulness practice. You actually have to slow your brain down to match the air inside the box. It really is.
Yeah.
And when you do it right, it works. Thousands upon thousands of growers produce pristine, contamination-free cultures this way every single day.
Now, I have to play devil's advocate here because I know myself, I'm impatient. Waiting 45 minutes for dust to settle it sounds annoying. And I don't have $500 for a real flow hood, so I go on YouTube and I see a tutorial. Build your own flow hood for $50.
The infamous fan filter unit trap.
Right. They take a regular old box fan, they tape a furnace filter to the front of it, and they turn it on. I mean, it blows air through a filter. Why is this such a bad idea? It seems like a brilliant hack.
It is a classic case of a little knowledge is a dangerous thing.
Mm-hmm.
The logic seems sound on the surface. Fan plus filter equals clean air. But a true laminar flow hood is a precisely engineered device.
Yeah.
It's not just a fan taped to a filter. The key component is something called a plenum.
A plenum? What's that?
A plenum is a pressurized chamber behind the filter. The big empty box, basically. The fan fills this box with air, and the pressure builds up evenly. This ensures that the air is pushed through the entire face of the filter at the exact same speed everywhere. It comes out as a solid, non-turbulent wall of air. Laminar flow.
Like that smooth water tap again?
Exactly. A cheap box fan doesn't have the static pressure to do that. It can't build up that even pressure. So it creates turbulent air. The air comes out choppy, swirling. The Reynolds number is through the roof, usually over 4,000 in those setups.
So it's just chaotic wind, even if it is a little bit filtered.
It is chaotic. And here is the absolute kicker. Because of a fluid dynamics phenomenon called vortex shedding and edge mixing, that very turbulence acts like a vacuum. As that choppy air blows out, it creates these little swirls at the edges that actively suck in the surrounding room air.
Hold on. So by turning on this homemade fan, I'm not just blowing okay air. I'm actually pulling dirty, unfiltered room air into my sterile zone.
Exactly.
Yeah.
You're entraining contaminants. You're literally building a contamination machine. You are taking all the dirty air in your room and focusing it like a fire hose directly onto your petri dish at high speed.
That is horrifying. So the $30 plastic box that does absolutely nothing is scientifically superior to the $100 DIY fan bill.
Without question. Because gravity is reliable. Bad engineering is not.
That is the headline for this section right there. Gravity works better than bad engineering. Before we move on from the SAB, though, there is one major safety rule we absolutely have to mention. Because we talked about alcohol, and we talked about an enclosed box.
The no flame rule. This is critical, non-negotiable.
Yeah. In a lot of laboratory videos, you see people using a butane torch or an alcohol lamp to sterilize the tip of their needle or scalpel until it glows red hot.
Which is a fantastic sterilization method in an open room or in front of a real flow hood. But think about the still air box.
Mm-hmm.
You just sprayed the inside with 70% alcohol. The air inside that box is saturated with flammable alcohol fumes.
It's a fuel tank.
It is a fuel air bomb waiting for a spark. If you stick a lighter or a torch inside that box and you flick it, best case scenario, you singe your eyebrows and scare the cat. Worst case, you melt the plastic box on your hands or cause a serious pressure explosion that can send shards of plastic flying.
Definitely not the kind of mushroom cloud we want to be making.
Absolutely not. And plus, even if you don't blow yourself up, the intense heat from the flame creates powerful convection currents. Hot air rises fast. That movement completely destroys your dead air stability you worked so hard to create.
So if you must use a flame, you flame your needle outside the box.
Flame it outside, let it cool for a few seconds so it's not red hot, then carefully bring it in. Or better yet, just use pre-sterilized single-use needles or other methods of chemical sterilization. Just keep the fire away from the alcohol box. It's not worth the risk.
Safety first. Okay, so we've sterilized our gear with our cheap 70% alcohol. We've inoculated our grain spawn in our cheap plastic box. Now, a few weeks later, it's all white and fuzzy. We've mixed it with our dirt, our substrate, and we're ready to actually grow some mushrooms. We need a fruiting chamber.
The monotub.
The monotub. Again, looking at this thing, it seems way too simple. It's another plastic tub, but this time with some holes drilled in it. But you're telling me there is some serious thermodynamics going on here.
It is a passive biological engine. That's how I like to think of it. It's an engine that runs on life itself.
Explain that. What's the fuel for this engine?
The mycelium. The fungus is alive. It's a living organism. It's metabolizing the grain in the substrate, breaking it down for energy.
Yeah.
And just like you and me, when it metabolizes, it generates heat. It's an exothermic process.
So the block of mycelium is like a little radiator. The inside of the tub is naturally warmer than the room it's sitting in.
Correct. Usually by a few degrees. And that small temperature difference is what drives the entire airflow system. We call it the stack effect or thermal buoyancy.
The stack effect. This is what architects use to cool big buildings without air conditioning, right?
Exactly the same principle. Warm air is less dense than cool air. It's lighter. Archimedes' principle tells us that less dense fluids float on top of more dense fluids. So the warm air inside the tub naturally rises to the top.
Okay, that's simple enough.
Now, a properly designed monotub has holes drilled near the top. We call them the high holes. The rising, warm, moist, CO2-laden air exits through these holes.
It escapes. It vents out.
But nature abhors a vacuum. If air is leaving the tub, new air has to come in to replace it. This process creates a slight negative pressure at the bottom of the tub. This pressure differential pulls fresh, cool, oxygen-rich room air in through the low holes, the ones you drill right above the level of your substrate.
So it creates this invisible, self-perpetuating conveyor belt. Cool air comes in the bottom, gets warmed up by the living mushrooms, rises, and then leaves out the top.
And it runs 24 hours a day, 7 days a week. It never stops. It doesn't need batteries. It doesn't need a fan. It doesn't need a timer. It just runs on the heat generated by the mushrooms themselves.
That is the essence of this set and forget philosophy.
It is. But this is where the new grower really struggles. They have what I call parental anxiety. They want to do something. They feel like they need to be involved.
Right. You just spent a month growing this beautiful white spawn. You put it in the tub. You feel like you should be helping it along. So you open the lid. You fan it with a piece of cardboard. You mist it with a spray bottle.
And every single time you open that lid, you are interrupting the stack effect. You are destroying the equilibrium. You're letting all that precious humidity out. You're letting dry room air in. You are completely disturbing the microclimate that the tub spent hours creating. The monotub, if designed right, breathes for itself. It knows what to do better than you do.
But there's a villain in this story, right? A waste product. We talked about oxygen coming in. But what about the exhaust? What are the mushrooms breathing out?
Carbon dioxide, CO2.
So they breathe just like us. In with the oxygen, out with the CO2.
They do. They respire. But there is a huge physics problem with CO2 in a closed container. It is heavy.
How heavy are we talking?
Well, the molar mass of CO2 is about 44 grams per mole. Oxygen is about 32. So CO2 is roughly 1.5 times heavier than the air it's in.
So it sinks like a rock?
It sinks like a rock. In a still environment like a tub, it doesn't just mix in. It pools at the bottom. It forms an invisible layer right on top of the substrate, exactly where your mushrooms are trying to form their little pins and start growing.
So it's like a blanket of suffocation right on top of the baby mushrooms.
It's a perfect analogy. And we see the direct result of this in a common problem called fuzzy feet.
Fuzzy feet. I've seen pictures of this online. It looks like the mushroom is wearing a little white fur boot at the base of its stem.
Exactly. That white fuzz growing up the stem, that is mycelium. The mushroom detects dangerously high CO2 levels at its base, so it frantically grows mycelium upwards, trying to literally climb into fresher air. Or another symptom is the mushrooms get really long and skinny. We call them leggy. They are stretching their necks, trying to get their heads above that invisible lake of CO2.
They are gasping for air.
They are. And this is why the placement of those holes in the tub is so incredibly critical. Those low holes we talked about, they aren't just for air intake. They also act as a drain.
A drain. Like a bathtub drain.
Exactly like a bathtub drain. Think of the CO2 as water slowly filling up the tub from the bottom. If you drill a hole right at the substrate level, that heavy gas can physically spill out of the tub and onto the floor, simply due to gravity.
That is a fantastic visualization. You're not pushing the bad air out. You're just letting it drain away on its own.
And this is where some of the more modern kit designs really lean into the physics. You mentioned rhizopods in the notes earlier.
Yeah, those little pre-made kits. They look like domes or something.
Right. If you look at their design, the substrate is positioned right at the rim of the container, underneath the dome lid. So when you vent it, there is no wall to hold that CO2 in. Gravity just dumps that heavy layer instantly over the edge.
There's no bucket for the heavy gas to get trapped in.
Correct. But whether you buy a purpose-built pod or you drill holes in a $5 Walmart tub, the principle is exactly the same. You have to respect the density of the gases you're dealing with.
And this is why simply cracking the lid often isn't enough, right? I see that recommended all the time. Just leave the lid unlatched a little.
It helps, but think about the physics again. If you crack the lid at the top, you're letting the warm, humid air out, which is good. But that heavy pool of CO2 sitting at the bottom, it's too heavy to rise all the way up to that crack. It might just sit there, stagnating. You need low-level ventilation or deliberate air exchange like wafting to physically move it out.
So we've covered the chemistry, the workspace, and the fooding chamber. And the pattern here is just, it's undeniable. All of these core solutions, 70% alcohol, the still airbox, the Monotub, they are the cheapest options available.
By a huge margin.
And they are scientifically the most robust and elegant solutions.
Yes, they work with nature, not against it.
But that gear acquisition syndrome is strong. We just want to buy things. So let's move to the part of our deep dive where we probably make some enemies in the retail world. We are going to do the do not buy list.
My favorite list.
I am going to read off items that are currently sitting in thousands of Amazon shopping carts, and you are going to tell me why I should click delete. Item number 1, heating mats.
Oh, the ceiling mats. I see them everywhere.
And I get it, though. I really do. New growers worry constantly about temperature. They think, my house is 68 degrees, but the guide I read says mushrooms like 75 degrees. I need a heater.
So they buy a mat, they stick it under their grain jar or their tub, and they crank it up.
What's the problem? Heat is good, right?
Two massive problems. First, as we already mentioned, the mycelium produces its own heat. It's exothermic. The inside of your jar or tub is already warmer than your room. If you add a heater from the outside, you can easily overheat it, pushing it into the danger zone.
And what happens when it gets too hot in there?
Bacteria happens. You see, fungi are tough. They can grow perfectly fine at 68 degrees. They just grow a little bit slower. But bacteria loves heat. By using a heat mat, you are basically creating a perfect incubator for bacterial fermentation.
You're not growing mushrooms. You're making a jar of rotten grain soup.
Exactly. You are speeding up the enemy much faster than you are speeding up your mushroom. The bad guys outcompete the good guys.
And what's the second problem?
Desiccation, drying out. Heating mats heat from the bottom up. This cooks the moisture right out of the grain or the substrate at the bottom of the tub, leaving it dry and cracked.
So you end up with a dry, useless cake at the bottom and a bacterial swamp at the top. It's the worst of both worlds.
Precisely. The reality is, unless you live in an unheated garage in Alaska in the middle of winter, room temperature is absolutely fine. Patience is your heater.
Patience is your heater. I love that. Okay, item number 2, humidifiers and foggers.
The reptile foggers, oh, they look so cool, don't they? You see the mist rolling into the tub like a movie set?
It looks like a scene from Alien. It makes you feel like a real scientist.
It does. But again, we have to look at the biology. Mushrooms need high relative humidity in the air around them. They do not, under any circumstances, need to be wet.
And there's a difference.
A huge critical difference. Foggers pump tiny liquid water droplets into the air. Eventually, gravity takes over. Those droplets fall. They settle on your substrate and on your mushroom pins, and they create pools of standing water.
And standing water is?
The #1 enemy. Standing water plus a nutrient-rich substrate is the perfect recipe for trichoderma.
The dreaded green mold.
The green monster. It absolutely thrives in wet anaerobic conditions. If you are using a fogger, you are essentially watering your mold garden. A properly made monotub retains the moisture from the substrate itself. The mycelium breathes it out, the walls hold it in, and it creates a perfect, humid microclimate naturally. You don't need to pump extra water in.
So throw away the fogger. But wait, if I don't have a fogger, how do I know if it's humid enough?
That leads me to item number 3 on the list. Cheap digital hygrometers.
Ah, the little black squares. You can get a pack of 5 for $10.
I have them in every room of my house. I have them in my guitar cases.
We all do. And they're fine for that. The problem is, those sensors are designed for cigar humidors or living rooms. They are reasonably accurate, around 50 or 70% humidity. But when you put them inside a mushroom tub where the humidity is supposed to be 95 or 99%...
They freak out. They saturate. The electronic sensor literally gets wet and stops working accurately. It can't tell the difference between 90% and 100%. It might read 99% when it's actually getting too dry, or it might read 80% when it's swimming in water. They are notoriously unreliable at high saturation levels.
So I'm making critical decisions based on a lying robot. How do I find out the truth?
You use the visual hygrometer.
Meaning?
Your eyes, your own two eyes. They are the best tool you have. Look at the walls of your tub and the surface of your substrate. You should see thousands of tiny, microscopic beads of water shimmering on the surface.
Like morning dew on the grass?
Exactly like morning dew. If you see those beads, your humidity is perfect. If the walls are dry and there's no shimmer, it's too dry. If you see big rivulets of water running down the walls or puddles on the substrate, it's too wet. It's that simple.
Trust the beads, not the batteries.
Always.
Okay, last item on the do not buy list, and this is the big ticket item, the one people graduate to. The Martha Dent.
Ah, the Martha. Named after Martha Stewart, allegedly, because of its resemblance to a portable wardrobe. It's basically a mini greenhouse with shelves all zipped up in a plastic cover.
It really seems like the natural next step. You start with a few tubs, you have some success, and you think, I'm ready to level up. You graduate from tubs to a tent.
And look, for very advanced growers who are doing bulk production of multiple species, or for someone growing very difficult species like pancyans that need specific parameters, they can be great tools. But for a beginner, it is a money pit and a contamination nightmare.
A nightmare. Why?
Because now you aren't just managing one or two self-contained tubs. You are managing the climate of an entire room.
Yeah.
You have to humidify the whole tent, which means you do need that fogger we just told you not to buy, which leads back to the standing water problem, which leads to mold. You have to manage airflow with fans and exhaust ducts. It's incredibly complex to get it dialed in correctly.
And what happens if just one of your trays inside gets a little bit of mold?
That's the real kicker. In a tent, all of your trays, all of your projects, they all share the same air. If one tub gets a spot of trichoderma, the fan you have running for air exchange will blow those green spores on every single other tray in the tent.
It's a super spreader event for fungi.
It is. It's a catastrophe. With individual monotubs, they are modular. They are self-quarantined. If one tub gets sick, you feel sad, you take it outside, and you bury it in the garden. The tub sitting right next to it is perfectly safe. A tent connects everything. It's a high-risk, high-maintenance setup that beginners simply do not need and usually fail with.
Man, we have really stripped this whole process down to its bare essentials. We've basically dismantled the entire shopping list of a new grower.
And we've replaced it with physics and patience, two things that are absolutely free.
It's funny, looking back at all of this, the obsession over 99% alcohol, the desire for a flow hood, the automated tub, it all points to one thing. We're trying to buy our way out of anxiety.
That's deep. Explain what you mean by that.
Well, GAS, this gear acquisition syndrome, it feels like we buy this stuff because we are deeply afraid of failing. We think, if I buy the expensive flue hood, then I can't get contamination. We are trying to buy a guarantee, an insurance policy against our own inexperience.
That is a profound insight. You're right. We are trying to swap money for skill or money for confidence.
Exactly. We think we can buy success in a box from Amazon.
But biology just doesn't work that way. The mushroom doesn't care about your credit card receipt. It doesn't care if your fan costs $200 or if your plastic box costs $5. It only cares about the fundamental conditions. Is it clean? Is there air to breathe? Is there food to eat? Is there water?
You know, I have a final theory about this. I think GAS is actually a form of procrastination.
Procrastination? How so?
Yeah. Think about it. As long as I am on Amazon researching which fogger has the best reviews, or I'm watching hours of YouTube videos comparing different flow hoods, I'm not actually growing anything. I'm preparing. I'm getting ready.
And if you are still preparing, you can't fail.
Exactly. You can't get a tub full of green mold if you haven't even inoculated your first grain jar yet. Buying gear feels like you're making progress, but it's actually a clever way to delay the scary part, which is actually doing the work and risking that it might not work out.
That is fascinating, and it's so true. The set and forget method is difficult for people, not because it's technically hard, but because it requires you to let go of control. It requires you to trust the process, trust the physics, and just wait.
And waiting is the hardest part of any new hobby. We want results now.
It is, but that really is the zen of growing. The best grower isn't the one with the deepest pockets or the shiniest gear. It's the one who is the most observant. The one who understands why they're wiping the box with 70% alcohol, why the holes are drilled in that specific location.
It's about being in tune with the organism, not with the equipment.
Precisely.
Well, on that note, I think I have some Amazon returns to process. I'm going to stick with my plastic box and my cheap alcohol.
A very wise choice.
And maybe I'll just sit and watch the dust settle for an hour. It actually sounds kind of meditative when you put it that way.
It's the best part of the day.
Thanks for listening. Happy growing, and don't forget to subscribe.